Okay, today's video lesson is on percent compositions. And percent compositions, or what is known as mass percent, is a way of looking at how a compound's mass is divided up by the elements that make it up. So if we look at this compound, okay, we say that this compound as a whole piece, we want to know how much of this is going to be made up of carbon, okay, how much of it's carbon, how much of the compound is made up of oxygen, and how much of it is made up of hydrogen. So we want to know what percentage of the C2H5OH is making up the compound. So we're going to break it up into pieces. Okay, so these are percentages just like you've dealt with in math. So for a percentage, what we need to do, in this case for a percent composition, what we're going to do is take our mass of each of the elements that we have, over the mass of the compound. We're going to multiply that by 100, just like you would for any percentage that you would deal with. You're figuring out what the part is over the whole. Okay, so to do this, let's take a look at the percent of carbon. Well, actually, before we do that, what we need to have is the molar mass of the compound. So if you know the formula, okay, if you know the formula, what we're going to do is we're going to use the molar mass to figure out the percent composition. Okay, so we just take the carbon. Since there are 2 carbons, we just go ahead and multiply that by 12.01. We take our hydrogens, which are equal, there's 5, nope, take it back, there's 6 of them. And each one of those is 1.01. And our oxygens are, we have 1 and they are 16. So add all these up. This is going to give me 24.02. This is going to give me 6.06 grams. And I have 16 for the oxygen. So add all these up, and what I end up with is 46.08 grams. So what this means is that the total mass of this compound is 46.08 grams. How much of it is made up of carbon, how much is making up the hydrogen, and how much is making up the oxygens. Now we're doing this by percent compositions, by mass, not by numbers. Okay, so even though I have more of the hydrogens, I really am looking at the mass. Even though there's 6 of these, carbon definitely contributes more. So to figure out the percent of carbon, what I do is I take that mass, 24.02 grams, and I put that over 46.08. So I'm taking my mass of the element I'm looking for over the total mass of the compound. So this is the mass of C2H5OHO, okay? So that would be my mass of the compound. Then I multiply this by 100, and I can get my percentage, which comes out to 52.1%. And that would be the percentage for carbon. Now I'm going to do the same things for hydrogen and for oxygen. And there we go. Pretty quick, huh? Okay, so I kind of did that fast so you didn't have to see the work, but it's pretty much the same thing. I just did it 3 times, changing the hydrogen mass and the oxygen mass instead of the carbon. And here are my 3 percentages. So you can clearly see that carbon does contribute more, just over half the mass. And it makes sense. 24 grams is 46 grams. And hydrogen, even though there's more hydrogen atoms in the compound, it's not very heavy. It's very light, so it's not going to contribute much to the mass, so therefore it has the lowest percentage. Okay, so let's take a look at another way that you can see these percentages, because you're not always going to have the the chemical formula. So we could, and the thing about percentages, by the way, it doesn't matter as long as you have the same compound. Just a little note here. These percentages are now locked in forever for this compound. This compound will always be 52% carbon, 13% hydrogen, and 35% oxygen. Always, always. Okay, so that's important because I can change these numbers to anything I want as long as these percentages are the same. So they're universal, and that's the whole point behind what these next problems are. Here I have a sample of unknown mercury compound. So here I don't know what the formula is, okay, and I can't figure out what the formula is. But what I have is I have the mass of the compound. Okay, and it doesn't matter if I have the empirical formula or not. So the mass of the compound, I meant the chemical formula. Empirical formula is coming up. That's why I keep talking about that. So here's the mass of the compound. in grams. What they tell me is when I decompose it, I'm going to break it down into mercury and some other substances. Okay, so we know that it's made up of mercury. So we have the mass of the element. In this case, my element is mercury, and it's 13.2 grams of mercury. Okay, so what I'm looking for is the percent of mercury in this problem. Okay, that's what I'm looking for. Why the mercury? Because they don't tell me the other elements. So since I only know mercury, not hydrogen, since I only know it's mercury, that's the only one I can use. It's the only percent I'm going to find. So I need to find the percent of mercury in this compound. This is pretty simple because I need to take the mass of the compound and the mass of the element. So 13.2 grams over 14. Now you can see they're pretty close to each other, so I should get a really high percentage. Make sure you think of that before you do the calculation, because you want to make sure you're getting the right numbers here. All right, so we do the calculation, you should get about 92.96, and if you use significant figures, and with significant figures, since I have 3 here, I'm going to put 3 in my final answer, 93.0% for the mercury. Okay, so again, mass of the element that I have compared to the mass of the overall compound. All right, now let's say that I switch this up. What if I have, what if my mass of the compound is equal to, let's say, 42.6 grams? Okay, so that's my mass of the compound. What is the mass of mercury? Okay, that's what I want to figure out. What's the mass of the mercury? Well, assuming that I'm talking about the same compound, as I said before, this percentage is always true. This compound, whatever it happens to be, is always going to be 93.0% mercury. So what I'm going to do is I'm going to take 93% of this mass. So I'm going to take and go 0.93, because I got to get rid of the percentage, and I multiply that by 42.6 grams. I take 93% of this mass to figure out my mass of mercury. So I'm breaking this up into 93%. So 93% of that would be 39.6 grams of mercury. So the point is, it doesn't matter what this mass is, mercury is always going to be 93% of whatever the mass of the compound is, as long as I'm talking about the same substance. All right, last problem. Here we have mass of magnesium combining with masses of nitrogen to form a compound. Now, you don't need the balanced equation here, but it kind of helps to see what's going on. So I got magnesium and nitrogen reacting to form magnesium nitride. Okay, so there's your balanced equation. Okay, so I'm starting with 9.03 grams of magnesium and 3.48 grams of nitrogen. Okay, so if I combine these, and it says here combines completely. If you guys remember the law of conservation of mass, the mass on this side of the reaction should equal the mass on this side of the reaction. So therefore, my total mass of compound, if these go completely together, will be 12.51 grams. Okay, so I'm just going to add these two together to get this total, because the side on the reactants must equal the products. So this is my mass of product, right? This is the mass of the product that I have. So if I want to find the mass percent of magnesium, I would go ahead and take 9.03 grams, put that over 12.51 grams, multiply by 100, and my percentage of magnesium, 72.2% magnesium. Now, most of you are going to be like, okay, couldn't I just subtract that from 100 and figure out what the mass of the nitrogen is? Yeah, you could. You could do that if you wanted. But if you made a mistake here, you don't want to make a mistake in this problem as well. So I would go back to the original problem and just do it one more time, just to be sure. Okay? So you just don't want to make too many mistakes in here. So divide these out, and you get 27.8% for nitrogen. Now these percentages are always going to go with the substance. So if I did this problem again later, I could change this and say, you know what, maybe instead of reacting 9 and 3, maybe I reacted a different number and I got maybe 84.6 grams of compound of magnesium nitrate. Could you tell me what the mass of magnesium was in there? Right? Couldn't you do that using that percentage? I'm not going to do it, but you can probably figure that out. Okay, that's mass percents. Thanks a lot, guys.